I'd like to now invite up Nathalie Boulanger from the University of Strasbourg, who's going to tell us about ticks and tick-borne diseases and their relationship to climate.
Hello, everybody. First of all, I would like to thank Rémy, Slama for the invitation, and I'm very pleased to be part of this research symposium. So I'm going to talk about ticks and tick-borne diseases and the potential impact of climate change on these vectors. Most of you know very well about mosquitoes because they are the vector number one of, in human health, because they transmit the plasmodium responsible of malaria. They transmit also worms responsible of filariasis, and also viruses like the one responsible of dengue, yellow fever, and Zika. However, if you consider human and veterinary medicines, ticks are vector number one because they transmit a large panels of pathogens like bacteria, for example, Borrelia, Anaplasma, and Rickettsia, parasites like Babesia, and viruses like tick-borne encephalitis or Crimean Congo hemorrhagic fever. To give you a general overview of these tick-borne diseases, if you consider the temperate zones, it's mainly human health which are affected by these tick-borne diseases. The most well-known of these diseases are Lyme borreliosis, but you also have anaplasmosis, tick-borne encephalitis, rickettsiosis, and so on. And considering animal health, it's more wild zoonosis. On the other hand, if you consider tropical zones, it's more domestic animals that are affected by these diseases, with babesiosis, anaplasmosis, and theileriosis, and human health, to a lesser extent, is affected by these tick-borne diseases, and it's mainly relapsing fevers, rickettsiosis, and Crimean Congo hemorrhagic fever. Worldwide, you have around 900 species of ticks identified, and they are divided in two main families: the soft-ticked or Argacidae family, and the Ixodidae family or hard ticks. And among all these ticks, I selected 3 of them to try to analyze the potential impact of climate on these ticks. I selected Ixodes ricinus, and I selected Yaloma and Rhipicephalus. Before going more in details into these 3 examples, I would like to give you a general overview of the biology of these ticks, because it will be very important to understand later the potential impact of climate. So you have different stages. You have male and females, and after mating, the females is going to lay eggs and die. From these eggs are going to emerge the larvae, and larvae are going to look for a first host, take a blood meal of around 3 days, fall on the ground, molt, and become a nymph. They look again for a new host. The blood meal is longer, 5 days. They fall on the ground, molt, and become adults. What you have to keep in mind is they are strictly hematophagous. They have long blood meals, and ticks rely strictly on vertebrate hosts to feed and to move on long distance. Other factors very important to understand the biology of ticks, it's the behavior, the way they live. You have some endophilic, so it means that they live very close to their host. They live either in burrows, nests, or wall crevasses in human dwellings. Or they are exophilic, so it means that they live on vegetation. They can quest on vegetation like Ixodes ricinus, or they can hunt very actively to look for their host, and it's the case of Yaloma marginatum. Other very important factors are the factors affecting the habitat. You have the abiotic factors, so temperature and humidity is very important. Some need high temperature, some need low temperature, some need a lot of humidity, some can live in very dry environment. And you have the biotic factors. So vertebrate hosts are very important. Some are very specific to one host. Some have no specificity, so they can live on a large panel of hosts. And the vegetation can be very important. It can be either very humid with a lot of forest, or it can be either very dry in desert. So I selected 3 ticks to try to illustrate the diversity of ticks and how they can adapt to climate change. So the first one, as I said, belongs to the Ixodes ricinus complex. It's mainly present in the northern hemisphere, and it has a lot of hosts, and is vectors of numerous diseases, like Lyme borreliosis, as I said before, tick-borne encephalitis, anaplasmosis. The second example I selected is Rhipicephalus sanguineus. This one is present in temperate and tropical zones. It has a main host, the dog, but if it doesn't find the dog, it can look for other vertebrate hosts, and is mainly vectors of rickettsiosis. And the third example will be Yaloma marginatum. It's present in tropical and Mediterranean zones. It has also diverse hosts, and is vectors mainly of Crimean Congo hemorrhagic fever. So the first example, Ixodes ricinus complex. As I said, this tick is present in the northern hemisphere with some specificity. In USA, you mainly find Ixodes pacificus on the west coast, Ixodes scapularis on the east coast, and in Eurasia, you find on the west side Ixodes ricinus, and on the east side Ixodes persulcatus. And if we look more in details in Europe, this tick is widespread, except in the Mediterranean region because it's too dry. This tick mainly lives in a forest ecosystem. It has a very long cycle, 2 to 3 years, even 6 years if it doesn't find the right host. And it's very sensitive to desiccation. It's something to keep in mind. So it lives in deciduous forest or mixed forest. And its main peak of activity up to now in continental climate, it's in spring, with a second small peak of activity in autumn. But if you are in continental climate, it's active all the year. So the vegetation on the ground will be essential to maintain the humidity essential for the survival of these ticks. This tick is called telotrope, so it means that it's going to feed on at least 300 different species. Rodents and small mammals like insectivores, leporids are very important, especially for larvae and nymph. For birds, it will be also very important for larvae and nymph, and birds are very important for the dispersion of these ticks. And large mammals are essential for adult ticks because the female ticks need a large amount of blood, at least 100 times its weight. So it's only a large mammal that will be able to allow the complete blood meal of these adults. This tick is well known as the vector of Lyme borreliosis. This disease is the first vector-borne disease of the northern hemisphere. As you can see, within the last 20 years, the disease was mainly present on the east coast of the States, and now it's really spreading toward the Great Lakes and towards Canada. And in Europe, we observe a similar pattern with extension north of Europe, especially in Scandinavia, as you can see. Here you have the spread northward of the tick. So which is the dynamics of this tick? Definitely the climate change is impacting the development of this tick and its repartition. It moves toward the pole and it moves higher in altitude. However, climate change is not the only reason of this expansion. Modification of the ecosystem is very important, like the forest management. Socioeconomic changing, and proliferation of certain tick hosts like rodents, cervids, and change on the flyway of migratory birds. The second example I selected is Rhipicephalus sanguineus. This tick is also very widely spread all over the world. In Europe, it's mainly present around the Mediterranean region. Its main host is the dog, and all the cycle can be maintained by dogs. If the dog is not available, the tick will look for rodents, birds, and even human. Compared to Ixodes cycle, the tick cycle here is very quick. Within 2 to 4 months, you have the complete cycle. The temperature is very important, so it's a thermophilic tick, and for sure, host availability is very important, and it's active in all seasons. This tick is well known as a vector of a bacterial infection called rickettsiosis. As you can see here in Europe, Africa, and India, it's a vector of Mediterranean spotted fever. It's a rickettsia. And in the Americas, so in North America and South America, another rickettsia is present. It's Rickettsia gonorrhoeae, responsible of Rocky Mountain spotted fever. Since this tick is thermophilic, we can expect that with climate change, the range of expansion of this tick and the associated disease are going to spread. It's what has been proposed here as the extension of the tick, but also of the rickettsiosis. And similarly in Europe, presently it's only Mediterranean region which are affected, but the tick could be more aggressive in a higher temperature, and then the rickettsiosis could move upward of the Europe. The dynamics of this tick population is very much linked to the dog. The dog is present in urban and rural area, and it can live very close to human dwellings. And since the dog is widespread all over the world, and it's a companion animal of the human, we can expect that the diseases could be present in all these continents because the tick is endophilic and thermophilic. The third example, it's Yaloma marginatum. This tick is mainly present in Africa, in Asia, and it's spreading towards Europe through Iran and Turkey, where it's actively circulating in these countries. The biology is a bit different from the 2 other ticks. It has also development relying on different hosts. But here it's what we call the 2-host tick, so it means that nymph and larvae can develop on the same host. And so it's generally small mammals that are involved. And for adult ticks, it's more ungulates, domestic and wild ungulates, which are involved, and humans are accidental hosts. This tick is very xerophilic and thermophilic, and it presents an ecological plasticity. It is well known as a vector of a deadly viral disease, which is called CCHF, and the cycle of in nature is quite complex. It can be maintained from tick to tick, so the virus is transmitted from larvae to nymph and to nymph to adults. The transmission can be horizontal, so from tick to wild animals and domestic animals. And humans are accidental hosts, and if a human is affected, it can be transmitted from human to human. In 2014, it was the distribution of this disease, but the disease is really spreading now towards west of Europe, and the last cases were recorded here in Spain, in 2016, 18, and 20. 6 cases have been diagnosed with 3 deaths. So there is now very active surveillance here in the south of France and in Spain, and to monitor the potential presence of virus, especially here in France, because the tick is present, but the virus up to now is absent. So within the last 10 years, you can see that there is a large spreading of this tick from Africa to Middle East here. And as I said, the last map, which has been published, shows the introduction of this tick in different places in Europe. How can we explain the introduction of these ticks in Europe? It's through migratory birds coming from Africa to Europe. And lately, so there is a clear record of the presence of this tick in Great Britain, in Luxembourg, in France, in Germany, in Netherlands. So, but up to now, because the climate is not warm enough, the tick is not present all the time. It cannot complete its complete cycle in Europe, except in Spain, as described before. So, which is really the impact of climate change on this tick dynamics? So for sure, the climate can impact directly the tick, because according, for example, for Ixodes ricinus, if it's too dry, it's not going to be active. So it can decrease its activity. It can, however, increase its length of activity. So generally during winter time, you have a diapause, so it could be suppressed. The climate change can have a direct effect on the ecosystem. So if you have modification of vegetation, vertebrate host, for example, is going to decrease the activity of tick. If this vegetation is decreased and the host availability is also decreased. Climate change can impact the mast production, and it's well known that if you have a large production of mast, it's going to stimulate the proliferation of rodent, deer, boar, which are vertebrate hosts for ticks, so it can have impact on tick reproduction. And also, we saw before, human activities can be impacted by climate change, so if people go more in forest, they can be exposed to more tick bite and more tick-borne diseases. The change in land use is also very important on the tick dynamics. It has been very well documented for several years that CCHF has been impacted by land use, and it's very well described in Crimea and also in Turkey. And after World War II, it was clearly shown that changes in agricultural practices have stimulated the proliferation of this type of host, so the hare, and the multiplication of ticks has been also largely increased. And in Turkey also lately, change in land use has also stimulated the proliferation of this tick, and there is a higher cases of CCHF. I mentioned previously that the tick development is very much linked to the presence of the vertebrate hosts, since they are strictly hematophagous. So the changes in migratory birds or movement in livestock or wild animals is going to impact the spread of ticks. Importation of exotic and wildlife species like amblyoma, which is another hard tick, can also allow the introduction of new ticks in new areas. And the movement of domestic animals is also responsible for the spread of these ticks. As I said before, for the dogs, it can spread very easily Herpescephalus sanguineus. And another hard tick is also expanding due to dog movement. It's Dermacentor reticulatus all over in Europe. And also the movement of cattle is well documented also as responsible of the spread of Amblyomma variegatum. So as you can see, it's not only climate change, it's also human activities and human practices that are responsible of the tick dynamics. So if I conclude on the ticks and tick-borne diseases expansion, the expansion is multifactorial. For sure, the climate can impact the tick activity, the tick habitat, the vertebrate host, and then the transmission of pathogen can be actively stimulated, and then you have a higher incidence of tick-borne diseases. However, we have to keep in mind, as mentioned in the different talks before, human activities is largely responsible of this tick dynamics and tick-borne diseases dynamics by its impact on the human practices and by its behavior is directly impacting all this system. If you want to get more information on these ticks and tick-borne diseases, this book has just been released, and you have the contribution of many different authors and its expert opinions on these different ticks and tick-borne diseases. And I thank you for your attention.